Hello, I'm going to do a quick demonstration of how one can control a second order plus dead time system using sliding mode control and a Smith Predictor. Here you can see I've got well, this is the output of the system, and I've got a set point, a process variable. This is my estimated variable, in other words, my current estimated state, and then the green line is a control output. And since we're controlling temperature, I assume we're just going to be turning on and off a heater, so the output's either on 100% or off. So you can see right here where it's on all the time while it's heating up, then it kind of pulse width modulates during the time that it's approaching the set point. What I have done is I have initially set the system gain, the plant gain, to 3 degrees per percent output. So right now I've got a random number generator that's randomizing that a little bit. I've got a time constant, an initial time constant of 3, and then a second time constant of 1, and a dead time of 151 seconds here, but normally it's 150. Let me just show you this. Go up to the beginning. This is where I set up the plant parameters to begin with. Okay, I've got a plant dead gain of 3, first and second time constants of 3 and 1. My update period is 1/60th of a minute or 1 second. I've got a plant dead time, which is 2.5 minutes, which is pretty long with respect to the time constants. And that equates to 150 seconds. Got an ambient temperature of 70 degrees. So here I am setting up my state space arrays. Then here's the trick. I'm assuming got a standard deviation of 0.1. So every time I hit the update button, my simulation button, it's going to change the plant parameters with a standard deviation of 0.1, by a factor of 0.1. So that kind of adds a random element, like an estimation error, because ideally I'd be using these parameters here. So this is just to simulate having a poor model. This is my estimator. And then coming down here, I've got the sliding mode control itself. That's the sliding mode control. It outputs either 100% or 0. This is the sliding mode controller. Basically, it just checks to see if this variable s, which I didn't bother to initialize here because I don't need it. But anyway, I just check to see if this term is greater than 0, and if so, it's greater than, I output 100, otherwise I output 0. This is my true state, my delayed state, and this is my current or estimated state. Then I have a routine to change the set points. Then this is where the sliding mode control gets called n times, or take my total times 60 minutes divided by 60, which would be about 3,600 times, I guess. So here is my response. So if I hit a Control F9, every time I hit Control F9, it will update the model with new random numbers. You can see the numbers change down here, and you can see how the model is going to respond up here. And again, this is simulating the process variable, what you would actually get. You can see there's the time delay, the dead time, and this is my estimated model using these parameters. So let me just hit Control F9 a few times. You can see here the gain is way down. You can see it's not estimating a high gain, but you can see that the control output is still very accurate. You can see the dead time. I'm not assuming that the dead time is constant at 2.5 minutes. I'm letting that vary quite a bit too. So here it's 160. Here I've got a dead time, or a time constant that's about 10% longer. Let me just hit the control update this a few times. And you can see that the control is actually pretty good, pretty robust, even though I'm changing the parameters over a very wide range. You can see that the estimated response, the EV, that's the predicted, doesn't always look like it's going to work. You see here the gain is very high, so it's estimating a very high response, but the actual response ends up being very, very, very close to the set point. The point is, the model doesn't really have to be all that good. You can vary it around quite a bit, and you're still going to be much better off controlling with the Smith predictor than you will be by just ignoring it and using some sort of reduced gains.